once an attacker is in your network, in your code, in a backup file, in somewhere, then one of the first things they're going to do is enumerate through all your data to try and find more secrets. Why? Because when you have a secret, you're correctly authenticated. If you break down a door, you're going to set off an alarm. But if you have a key for that door, then no one's going to be suspicious. It's exactly the same in IT. You're working within the expected parameters. So therefore, no one really knows that you're in there. So you can squat. You can kind of do your reconnaissance.
Hello, everyone. Welcome back to another episode of the 401 Access Denied podcast. I'm the host, Joe Carson. It's a pleasure to be here with you. And it's so exciting. I really enjoy having the amazing guests on the show. Really makes a difference. And I'm again joined by another amazing guest, somebody I've met quite a number of years ago already. So welcome to the show today. Welcome, Mackenzie. Tell us a little bit about yourself, what you do, and even some things that, maybe people don't even know about you.
All right. Yeah, great to be here. Thanks for inviting me, Joe. So Mackenzie is my name. I'm the security and developer advocate at GitGuardian, which is a security vendor. Before that, I was the co-founder and CTO of a company in Australia called Compago, which still exists today. Something that most people don't know about me. I grew up in the circus. So I have the extreme hippie parents. We were always traveling around. And I decided to rebel and get into IT and tech, wear suits and
another circus. You joined a different type of circus. We joined the technology circus because sometimes that's what it feels like.
That's for sure.
So, but it's great to have you on the episode today. I'm really excited about today's conversation because it's something I think we've in previous episodes we've had a few people touch on it. We've had Dustin Haywood, also known as Evil Mog, and we had Carlos Pull-Up, and we touched on a little bit, which is all about secrets. And one of the big themes, today's episode is all about, were our attackers looking for secrets, and what are secrets, and how are they discovering them, and how can they abuse them? And ultimately, of course, secrets can be a form of many things. It can be passwords, it can be tokens, it can be keys, it can be, simply just hard-coded passwords and passphrases. So secrets is basically that, top terminology for everything, even pins, etc. So one of the things is, this is something that you specialize and look into and, spend a lot of time on. Where are the attackers looking for and discovering secrets today? What's the places that they're finding them?
Yeah, well, just about everywhere. When you look at, a good place to start is the OWASP top 10. When you look at the OWASP top 10, what number one is broken access control, and within that it's leaked credentials or unprotected credentials, which is basically talking about secrets. So, where we find them, it really depends, and it depends on what the attacker is trying to do, because secrets are very unique. They can be used in so many different parts of an attack. So they can be your initial access. So if we talk about initial access, how do attackers find secrets initially and kind of break into an organization? Well, there's a lot of places. At GitGuardian, we recently just released our State of Secret Sprawl report. Now, in this, we scan public GitHub repositories, and we scanned every single commit that's made throughout the year. So in 2022, we scanned over 1 billion commits.
Whoa.
Of those billion commits, we found 10 million secrets. Now, bearing in mind, this is just in public repositories. And these are things like cloud provider keys, their database access, their API keys, and we can actually verify a lot of these. So we check with the provider, hey, is this a valid key? So we can be pretty sure that number, 10 million, this isn't just kind of random strings that look like secrets. These are pretty accurate. So going back to that initial access point, let's look at public GitHubs as initial access. Last year, a company called Toyota, you may have heard of it. They have an application called T-Connect, and they had a consultant working on this application. 5 years ago, they accidentally open sourced their source code for this. They had it accidentally in a repository. There was a secret inside there that gave access to the entire databases of all T-Connect users. So this is an example of how an attacker found a key in a public space, used it to move into a system.
Hmm.
Another example is we also scan for secrets in places like Docker Hub in
Hmm.
Docker images. About 5% of Docker images contain an extractable plain text secret. A few years ago, you may remember there was a big breach with CodeCov, a
Hmm.
supply chain attack. How that all started, and all these companies were breached as a result of that, including massive ones, Rapid7, Twilio. How all that started? A leaked credential in a public Docker image
Yeah.
on CodeCov's. So,
And what
so I
you're
mean,
also
like,
yeah, you're also finding a lot of even developers who are trying to make sure that they have ease of access. And even the last 2 years or 3 years,
mhm,
people working remotely. So what they've done is they've cloned repositories which were originally private and copied some of those or forked it into their own repositories and
absolutely.
which are now public. And you just hope that that they have changed or rotated the original token that was used before that happened, but it's not always the case.
Yeah, that exactly right. I mean, there's so many places. You got to remember is that source code is a very, very leaky asset, right? So, okay, we've got a private repository. What happens? All right, immediately that source code hits that private repository. It's then cloned onto all the developers that are using it. This
Hmm.
could be everyone in the company. It's backed up. It's probably in a wiki. It's shared on messaging systems, code snippets. So code you can never trust. It's in one spot. So, if you're going to have secrets in there, it's a very unreliable place, and they definitely can end up public.
And a
You know,
lot of developers are now using things like ChatGPT to analyze
yeah,
code, and of
yeah, yeah,
course
yeah,
that ultimately becomes eventually public because you can now query, and if it's actually getting embedded into its machine learning and into its actually data source, all of a sudden now you can start asking questions about code that it's been actually analyzing.
yeah, for sure.
So another interesting way that I've heard, a lot of reports that companies are now asking their employees not to go and put code or actually analyze it in things like ChatGPT.
Well, employees never do things that they've been told not to do, so that's foolproof. But did you
Absolutely.
know this was a bit of a side note? Did you know ChatGTP got a bug bounty last week?
Oh,
It's,
I didn't know. No.
yeah, yeah. So our I mean, this is a bit of a left field thing, but
Mhm.
it was actually a guy that was asked to evaluate EDR solutions.
Mhm.
And one of the ways he wanted to see, hey, if I create malware that's designed to bypass this, can I bypass some of these
Mhm.
solutions as a way of evaluating them? He didn't know how to write malware, so he asked ChatGPT. You have to trick it.
You have to
It
trick
won't
it.
do it
It's
initially. You
it's
have to trick it.
a special way
Yeah.
of asking ChatGPT to do something.
Well, you just kind of have to go, hey, can you give me an example of something that does this? And then you got to work through it from there. But eventually it spat it out. He managed to bypass some EDR solutions and then submitted it to their bug bounty program with malware that ChatGTP wrote and got a payment of, I think it was $650. So like
Okay,
not a
it's pretty
$50 bug.
it's pretty good if you can automate
Yeah.
that. That's the impressive part. If you can take that to the next stage, because
Yeah.
I myself I use ChatGPT a lot for things like to create the base of a code for myself. To with
Hmm.
certain parameters and outlines. But of course, I had to change it quite a bit in order to get it working fully functional.
Yes.
But I do see this as a way to do a lot more automation, to do things in a way to even getting it going and searching for things. So it might be even an interesting area for it to go and discover secrets.
Yeah, definitely. And I'm sure, and see, ChatGPT is great at things that humans aren't. Humans aren't good at discovering secrets because they're buried in code. But there are things like ChatGPT and other analyzers out there. Well, what we think at GitGuardian is that the problem of detecting secrets
Hmm.
will be solved from the engine point of view. So, GitGuardian has what we consider the best secrets detection engine that's available on the market. We have put lots of resources into this. We believe that in a few years that's not going to be novel, that
Hmm.
because with AI, with machine learning, with the huge data sets that we have, we're going to be able to get to a point that's really high accuracy, and everyone will have that. So that's really interesting. And these are the areas where AI. So it's going to be helpful. It's going to be
So
harmful and helpful at the same time. And I think you have to use it. You have to be
absolutely,
onto
you
this
you
because
you have to be knowledgeable about kind of where your data is and where your
yeah,
credentials are and where your access is coming from. You had to, you're better doing it proactively than waiting and to find out when something goes wrong, because ultimately that's the abuse that happens. Question: what types of malicious activities can be done when those secrets are obtained? Of course, getting an API could allow an attacker to extract data from a database, or it could allow them
Hmm.
to put some code into, or even if they got access to, they could even check in their own code into those repositories as well if they have the ability to do commits. What are
Yeah.
other types of activities you're seeing malicious actors doing when they're able to discover secrets?
Definitely. There's a couple of ways to kind of go in here. An interesting experiment that I've done quite recently is leaking a honey token into GitHub, which is a token that will kind of give me information about people trying to that have been exploiting it. So we can basically watch what hackers do. What they do when they find a credential is they automate through a process of like, hey, is this valid? That's number one. And then they kind of go through. So if it's like an Amazon key, it's like, does this have access to S3 buckets? Does this have access to that? Can I create a user?
Hmm.
So regardless of the type of secret, when an attacker finds something, they're going to be doing a couple of things initially. So they're going to do reconnaissance of what does this give me access to, and then they're going to move to how can I persist my access.
Hmm.
So can if this secret gives me access to, let's say, a code repository, can I find more secrets in that code repository? Can I create a new user for myself? Can I do all these different things, because they kind of at the moment I'm relying on this key that
Hmm.
grants me access into something.
That could be
How can I
changed at
move
any
into a different
time.
system? Yeah.
Yeah.
Yeah. How can I move into a different system? How can I ensure that my access is going to persist? How can I elevate my privileges? So that's what's going to
Hmm.
happen. And this kind of brings us off into the other area of attacks where, let's say that a secret is not the initial point of access. Then once an attacker is in your network, in your code, in a backup file,
Hmm.
in somewhere, then one of the first things they're going to do is enumerate through all your data to try and find more secrets.
Hmm.
Why? Because when you have a secret, you're correctly authenticated. If you break down a door, you're going to set off an alarm. But if you have a
Yep.
key for that door, then no one's going to be suspicious. It's exactly the same in IT. You're working within the expected parameters, so therefore no one really knows that you're in there. So you can squat. You can kind of do your reconnaissance.
The stealthy scenario,
Stealthy. Yeah.
absolutely. Yeah, I will say it's one of the kind of attackers prefer to be able to live off the land and reuse your credentials and access, because the moment
Hmm.
they create anything new, they create ripples in the water, and you're always looking for that
Yeah.
noise. And the most stealthiest methods are the preferred methods, and it allows them to typically stay around for a much longer period of time, so they can do a lot more reconnaissance and look for a lot more sensitive data, and to learn more and to look for ways to elevate. So definitely keys, which would basically allow the attacker to come in under the disguise of an application or a system or an access that they would typically see commonly. And they're
Mm.
disguising sometimes even the path and the route into those organizations. So absolutely, this is the most preferred method, I believe, from attackers, because it allows them to remain undetected for as long as they possibly can.
Yeah, exactly. And secrets are just a fantastic way of being able to remain undetected, especially if you kind of don't have the additional elements of zero trust set up.
Hmm.
So you haven't restricted IP scopes, or there's other types of authentication going on in the background. Which the honor like when we look at security, we have all these elements like zero trust, and they're
Hmm.
all great. And when you put them in, like multi-factor authentication, but the reality is that we're the standard is so far from the bleeding edge
Hmm.
of what we have, is that people always say, well, isn't this a solved problem? It's like, well, it could almost be a solved problem if we correctly utilized everything, and if every
Hmm.
organization had an unlimited security fund. Then
Yeah,
yes, yeah, we have
absolutely.
the technology to be able to do it, but the reality isn't there yet.
Yeah, no, it was interesting. So recently, I did a webinar with RSA that was just a recap of my talk from RSA last year, which was all about ransomware. And one of the questions that the audience had was that what would be some of the steps and methods that maybe this organization who became a victim of a major ransomware attack could have prevented it. And ultimately, what would happen was, when you go through all of the forensics and the logs and everything, one of the biggest things was that initial access. And the initial
Hmm.
access itself, it came from an authenticated credential. And that credential, we still don't know how that credential was done, whether it was through password reuse, or whether it was through credential compromise or phishing, or there's many different ways that the attackers
Yeah.
can gain access and discover those secrets. But ultimately, when you look at the logs and that first ever initial access, so for example, the accountant who was accessing this machine, whose credentials were compromised, they were coming all the time from a known IP address. The IP address was always the same, roughly, all the time, accessing the server. And then all of a sudden, the malicious actor had access to the credentials, and they came and they accessed the same RDP from a known Tor exit node, which is basically known to have a malicious reputation. And then
Right.
a couple of months later, saying they verified the credentials, they double checked it, made sure it was still working, made sure it was still something that, of course, they were likely an access broker looking to sell on that access later. But
Hmm.
again, another IP address that was coming from an exit node that was known to be malicious. So you end up, and the question is that if that organization had been looking through those, there is technology that looks at the reputation of IP addresses for suspicious, even just to get notification on it,
Hmm.
would give them at least something. But as your point is that all these technologies are out there. um, you know, why we haven't adopted many of them? Why is organizations still continually falling to these sometimes simple types of attacks? And what things can they do to prevent them? What some of the better practices? That doesn't mean they have to have every single technology under the sun, because I don't think when security budget is more than what the revenue profit of the organization makes,
Yeah.
that's
Yeah.
not what it's not going to happen.
No, I mean, it's exactly right, and I mean, there's so many. It's such a difficult equation because
Mm,
on one side you're like, hey, there's all these tools that could prevent it, and the other side is like, yes, but we're inundated by security notifications as it is. We don't
mhm,
have the team to be able to investigate it. But if we look at secrets, it's like, what are the most common ways
mhm,
that these secrets actually leak out? The number one where it happens is through source code. And we're generally talking about machine to machine
mhm.
secrets rather than human secrets,
Yes,
because if we're talking about human secrets, then then the answer is phishing campaigns.
correct. Yeah.
But when we're talking about technology, it's source code. It's the leakiest asset, and we have private source code. And like, I've talked a lot today about public spaces, but
Mhm,
private source code is much scarier than public. The reason being is that we're comforted behind this very flimsy layer of authentication when it comes to source code. Now,
mhm,
the problem isn't really authentication here, because source code isn't designed to be sensitive.
mhm,
And there's a case that it really shouldn't matter too much if your source code is open sourced. But we have behind this layer of authentication, but so many people need to access it. So many people have access to it. It's really hard to lock it down, and I wouldn't really
mhm.
recommend it. So one thing we need to do is we need to make sure that source code doesn't have secrets in it. So
Yes, hard coded,
eh,
yeah, or
yeah,
static. Anything that's persistent
yeah.
should that's definitely one of the main areas, is to get rid of that.
Absolutely. And it's super easy for it to happen because people go, "Oh no, we have code reviews. We
Mhm,
check everything. No, a secret wouldn't end up." But it's much, it's much more common than that, because
mhm,
imagine a scenario: you have a developer working on a development branch, and he's just trying to quickly get some database connected, something to work. Hard codes it
mhm,
like, yeah, we're going to remove it later. Hard codes it gets it working. Yeah, they've removed it. 30 commits later, that feature, that segment is now ready to merge into the main branch. Code review happens. You're not going to review every draft someone and every mistake someone made along the way. No, you're just going to review the latest version. It gets pulled in. No one sees a secret. It's in the history. You've got to remember that when most security vulnerabilities, they exist in the final version of the code. If I have cross-site scripting vulnerability in my code, I fix it, I update it. That doesn't exist anymore. Secrets persist for the lifetime of that secret is valid. If it's in the history and it's valid, it's a risk. So we need to make sure that secrets are not in there. How we do this, there's no magic bullet. There's education that we need to make sure that developers know not to do this ever, and how Git works and why it's a
mhm.
risk. We need to be using secrets managers. and something about secrets managers is there's some great products out there. HashiCorp Vault, in my opinion, is probably one of the best tools for managing secrets. But if you're a team of 10, it's not going to be the tool for you because it's too heavy. Like
Hmm.
it has too, so you have to try and find what is the correct tool for you to use that your team is actually going to use and that you have resources in place to manage it correctly. Because maybe it's not going to be something like Vault that you're self-hosting.
Yeah.
And then of course, scanning for these secrets yourself. You need to be notified when these secrets enter in your source code. They're going to enter in. You can put in something simple like a Git hook on your developers' machines, so that if your commit has a secret in it, it gets blocked,
Hmm.
doesn't enter the source code. So there's these things that you can do. And a cool resource that we wrote is the secrets management maturity model. It's basically just
Okay.
a survey that you can take to see like, hey, whereabouts are you in this? How much of a risk is your organization
Yeah.
having at leaking out these secrets? And I think there's like 20 questions or something about, or maybe less than that, and it will kind of
Mm.
give you what is your maturity level in managing secrets.
What's your current state in that level?
Yeah,
What you're doing and what you're not doing and what you should be doing.
exactly. Yeah, and what areas? Because it's not
Mm.
like you're either good or bad, right? It's okay. This is a good area, and this is big risk.
Does question, from a lot of the research and stuff that you've been doing, what about a lot of organizations? Developers are not always direct employees. They're third party sources.
Hmm.
They're external. They're third suppliers. Is that a major risk that you're seeing in organizations where they're basically just getting code from third party sources?
Yeah, huge risk. So, like in the managed service provider
Mm.
avenue, it's so when we're talking. Well, I talked about Toyota before, so that was
Mm.
from a service provider. That
Mhm.
wasn't theirs, and this is why this gets really interesting. Philosophy reasons. Organizations don't have visibility often into their consultants, their MSPs, and what they're
Mhm.
doing. So when it comes to like leaks on GitHub and areas like that, this all happens outside of your visibility. All of it.
Mhm.
It could be an employee from an MSP that's pushed something public that you don't know about. So it's a big risk to be able to do it. So we need to be careful in the providers that we're
Mhm.
choosing, and that they actually accept that this is a risk, because if someone says to you, "Oh no, that's not a risk for us. We wouldn't do that," then that's the biggest risk that you have
Mhm.
is definitely that. So just making sure that we're all understanding that this is a risk, and then getting visibility into what
Mhm.
kind of mapping out your perimeter and your risk factors, your attack surface, and including things that are outside of your control. You need to be able to be aware of that.
Absolutely. You gotta make sure that, well, while you might have good practices in place for your own developers, I've seen I've seen a lot of developers copy paste,
Yeah,
and sometimes when you're just copying code with secrets into your own code repository with secrets, and it's not
yeah.
always a good way to get things done. So what things what are some of the best places for organizations to start, and what would be the first kind of stepping point, of being able to go down the path of getting in control of secrets?
Yeah. So the first thing that you need to do is understand your risk. So look and scan your infrastructure. So your source code, your networks, other areas. There's vendors that do that, like GitGuardian, but there's also open source tools if you don't have budget for it, right? That um, where you're going to need more advanced tools is when you get really big as an organization. So understand your vulnerabilities. So scan your repositories, your networks, and get visibility into it. It's going to be shocking. We typically find that the average organization size of 400 developers, so still quite small. So about
Hmm.
400 developers, maybe 1,000 employees. They will typically have around about 1,000 secrets in their repositories. 1,000 unique secrets, 13,000 total secrets is typically what we find. So you kind of need to get visibility over that. And then there becomes this oh crap moment, because it's kind of like, now that we're aware of the problem, we have to do something about it. So you need to put in place good remediation. Then you're going to need to stop the bleeding. So why did this happen? When you get visibility, you can say, hey, these are the teams that are leaking. Why are they leaking? maybe that we're not using the correct secrets manager. Maybe we're not using the right amount of tools. Maybe how we're sharing these secrets is through Slack.
Hmm.
Whatever it is,
Yeah.
once you have visibility, you can plug your holes. And then you need to layer on backups. So once we've got visibility, we have correct tooling in place to be able to manage secrets. We need to be able to monitor in real time when a leak happens and
Hmm.
remediate the leaks that have happened. And remediating, I mean, it sounds like, hey, if we find the secrets, we can solve it. Remediation, especially at scale, is probably one of
Hmm.
the most difficult things because you're involving multiple parties. So you really need to look into the remediation process of it. But that's basically the steps that you can take to try and identify and fix the system. Identify the vulnerabilities, use the
Hmm.
correct tools to be able to find it, and then remediate and monitor in real time when they happen. Because they will continue to happen no matter what you do, but we just need
Yeah.
to be aware of that. Yeah,
Yeah, you absolutely need to be aware of the risk, and then make sure you've got tools in place that'll definitely allow you to monitoring that type of things. One of the things that we've been doing even at Delinea is around the ability to make sure that you're replacing those hard coding tokens with basically on demand, temporary tokens that
yeah,
allow you to get access, and you check out those tokens temporarily in order to perform an action. So it's definitely a way to make sure, and it gets you away from that static persistent secrets,
exactly.
which is what the kind of the major challenge is that when those secrets are out there and they're persistent, and you would need to change everything in order to remediate it, moving to more temporary based keys that has additional security controls and monitoring in place will definitely give at least organizations much better visibility and
Mhm.
know what things they can do in order to reduce the risk as well. So absolutely. So
Dynamic secrets are amazing. Like there's a few vendors that do that
mm,
now. Like Vault's been doing it for a while, but I also think a keyless, which is another secrets manager,
mm,
has features like this. I really think that this is got to be. It doesn't solve the issue completely because we have long life secrets behind short life secrets, but it
yep,
does. But I mean, like, hey, we before we can solve it, we need to get better, and this is a big step towards it. No, that's
absolutely.
it's very cool.
Yeah, it definitely allows you to move away from having it, having to change everything on the edge, everything in the
Yeah,
code, where you actually have a little bit more centralization and visibility into how those secrets are being used, when they're being rotated, how many machines have actually been and code has been actually communicating with it. So it gives
yeah,
you much better visibility, and it's also one of those things where at least I think the big challenge here is not only getting it from the source code, but also moving it into DevSecOps and DevOps, where it's getting into configuration files. That's all about basically doing code on demand, code basically serverless and codeless infrastructures, and it all ends up being in configuration files as well. So we have to make sure that not only is it just about in the developers, but also in the operational side when developers are actually getting the code into production.
yeah. I mean, and you bring up some great points there. And the one thing that I will say, that I didn't mention before is even if you're not got dynamic secrets, have a plan
Mhm.
in place to rotate secrets regularly, because this actually does a couple of things. One is it means that the secrets, obviously, if they do get leaked in code, they will be rotated and
Yeah.
worthless soon. But it also means that you actually know how to do it, so that if one does leak publicly, then you're like, oh, we know what this key does. We know how to rotate it. Because if a key, nothing worse than if a key
Mhm.
leaks, it's like, hey, what does this key do? It's, we have no idea. And like, okay, should we rotate it? Are we going to break everything? Like
That's
that happens
That's
when
the
it happens.
scary part. That's the
Yeah,
scary part for organizations, and that's
yeah,
sometimes why they don't rotate keys is that they don't know what they're going to break. They don't know what the
exactly.
relationship or the
Yeah,
the functionality of harmony. What does that key need to be the same in different places? So that's one of the things actually in Delinea as well. What we've done as well as dependency mapping of services, which use keys to communicate with different resources, and then making sure that you have the ability to rotate them all in the right time in the right places. Because I came from, my background many years ago was in backup and recovery and backup solutions. And when that key wasn't right in all of the right places, your backups weren't working. You couldn't recover. Reports started to
mm,
failure. And people were afraid to rotate those credentials. But once you have visibility into the dependency of those, you can do it much more, let's say, calmly and safely without worrying that you're going to break the application very quickly.
yeah, definitely, definitely.
So it's been fantastic having you on the episode today, and I think it's really important that kind of people get more visibility into the importance of keys and secrets, and where they can be discovered, what things they can do. Any final words of wisdom that you want to share with the audience into any good resources that they can go to? You mentioned the report that you'd
Yep.
released. Where would it be a good place for them to get the report and take a look at that?
Definitely. GitGuardian does a lot of research into this topic. It writes a lot of white papers. So the gitguardian.com is where we have a great resources page. The blog.gitguardian.com is also great. We publish every day on our blog, or just about, with uh, news and topics and trends and tutorials and everything. And it's quite agnostic, vendor agnostic in there. So they're great resources to check out. And I think that will be my final words of wisdom will be to try and just educate yourself around this problem, because it is growing, and it unfortunately it's affecting everyone in the industry.
Okay, absolutely, very wise, and we'll make sure to put them in the show notes so that everyone can get easy access to them. And the last question I've got is that do you go back to the circus these days or not, or what's are you afraid of circuses or what's
I used to be able to do so many fun tricks, and as I've gotten older, and like these tricks only really come out after a few beers, but I've really started injuring myself. So like I try to avoid all my old circus tricks and days. When I was 13, your bones were bendy, but now I, I don't think I don't think it. But
I think
it
the
would be
next
cool to try and brush up on some of the tricks again. I might.
Let's
Who knows? Maybe at RSA this year,
I
I'll
will try and
juggle some
put you to the
fire.
test for that. We'll see for sure. So, but it's fantastic having you on the show, and really, fantastic. And for the audience, hopefully, you've got a better idea around the challenges that many organizations have around secrets that are kept in a lot of source code and repositories. Whether it being private or public. Whether it being synced and backed up on employees and developers' devices. So it's really important that you get a visibility and get started on taking a look and how you can manage and reduce the risk today. So Mackenzie, it's been fantastic having you on the show today. Thank you. Hopefully, we'll be able to have you on back again in the future. And for the audience, this is the 401 Access Denied podcast. I'm Joe Carson, the host of the show. It's been a pleasure. Again, tune in every 2 weeks. Even go back and take a look at previous episodes if you want to find out more about some of the previous guests who've been on the show. So thank you. Stay safe and take care. Goodbye.